Okay. All right, guys, let's get started with, today we're going to be doing related rates again, but this time with similar triangles. And I just wanted to see what you guys remembered about similar triangles. Anything? No? Yeah? Okay, yes, that's what makes them similar. All the angles are the same. And then what do we know about the lengths of the sides, of corresponding sides? Yeah, they're proportional. Nice. So, so you have these two triangles in this first one here. Um, they're similar. You have the little one and the big one. So they're different proportions you can write as long as you're consistent or doing the same thing on both sides. Can anyone give me one? Remember, a proportion is just stating that two fractions are equal, right? Anyone want to try? Yes, Halas. R over H is equal to 6 over 10. That's right, because he looked at the little one and he said this side is to this side in the little one as this side, oops, is to this side in the big one. Very nice. Anyone write a different one? You could have done something like 6 over R. If you could do big is to little, right? 6 over R. Then what would the other side of the equation have to be? 10 over H. Now, either way, once you cross multiply, you have the same equation, okay? You see, they're actually the same. All right, good. Now, this one over here, X is only this part, and then Y is only that part. So this one, you got to think a little bit more. Anyone want to try that one? Setting up a proportion? Yes, Savannah. Nice job. Okay, so let's see what she did. She said X is to, I'm going to try to be color coded, to 2 and the little one as this side, X plus Y, I don't know what I'm doing with the colors, oh well, is to this side, the 5 in the other one. That was good. You see how you had to add them to get the whole side of the larger triangle? Right. So, and you also could have just done little is to big as little is to big. You could have gone 2 over 5 equals, what would the other side be? X over X plus Y. Or you could have said big, you know, big is to little. 5 over 2 is equal to Y plus X over X. So different ways to write a proportion. But we're going to be using that today because we're going to have similar triangles. So let's first go over the homework. So just check your answers. You got them right? Nice. Okay, what about questions? What questions do you have on these? Yes. 7. Let's go to 7. Oops, where's my 7? I must have had it back on this one. 5. Oh, here it is. Oh, all right. Well, this might be overwhelming for you. Maybe I should take a picture of it. Well, let's just see. First of all, so you have this kite. It's flying away, right? And a girl's flying a kite at a height of 320 feet. So the height of this kite is not changing. So that's why I could put a 320 on it. That's shown in the, but as it's being let out, the wind blows the kite horizontally at a rate of 15 feet per second away from the girl. At what rate is the girl releasing the string when the length of the string is 400? So you had to realize that this length is changing. I called it X. And the length of the string is changing as the kite is going out. I called it Z. Maybe I should have called it Y. Then you could figure out what derivatives they gave you. So since the kite is going horizontally at a rate of 15 feet per second, that's your dx dt, right? And that's positive because x is increasing. And they want to know at what rate is the girl releasing the string. So at what rate is this length changing? What's dz dt? when the length of the string is 400 feet, so when z equals 400. So that's the whole setup. Okay, so now we need an equation, and yesterday we were talking about right triangles, so in this case we could use Pythagorean theorem for our equation. So we write the equation, x squared plus 320 squared equals e squared. Then we can take the derivative of both sides with respect to t. So we get 2x dx dt plus 0, so I didn't write it, equals 2z dz dt. Now we can plug and chug. Now, we know we're going to plug in 400 for z, and we know we can plug in 15 for dx dt, but we still have to figure out what goes here for f's, right? Okay, where am I here? Oh, that's a different one. I guess I never finished this one. Okay, oh well. So let's see. Oh, so when z is 400, can we figure out what x is? Yeah, right? So if we use this equation here, I started it, but it doesn't look like I finished it. Did anyone actually do this and tell me what x turns out to be? Yes? 240? Okay, so x equals 240. So that's the value we got to plug in here. Yeah, with those right triangle problems, a lot of the times when they give you, at whatever particular moment, you got to figure out the length of one of the other sides with Pythagorean theorem at that moment. And then you can just multiply and divide by 400. Okay? Other questions on the homework? Yes, Ross? Number 5. Yeah, that one looked interesting. Just looking at that. If the rope is being pulled, oh wait, I don't think I'm seeing the whole thing. Okay. A canoe is being pulled toward a dock by a rope attached to its bow and passing through a docking ring on the dock. Okay. The surface of the dock is 3 feet high, higher than the bow of the canoe. So we've got 3 is not changing. If the rope is being pulled at 1 foot per second, how fast is the canoe approaching the dock when 14 feet of rope remain between the dock and the boat? Okay, so let's label something. So this guy, he's pulling it in. So you want to call this one X? What do you want to call the length of the rope? Z? Sure. Okay. Okay, so let's see. What derivative did they give us? The rope is being pulled at 1 foot per second. Yes. Yeah, they gave you dz dt. Now, would you say that dz dt that they gave us, the rate at which z is changed, should be positive or negative 1? Negative. Negative 1. That's good. How fast is the canoe approaching the dock? So what are we looking for? Dx dt. When 14 feet of rope, there's something on your desk for you. When 14 feet of rope remain between the dock and the boat. You're welcome. So when 14 feet of rope remain between the dock and the boat. Yes. When z equals 14. Okay. So that's the setup for this one. Now we can just start with Pythagorean theorem for the equation, right? So we have 3 squared plus x squared equals e squared. We'll take the derivative of both sides. So when we take the derivative of both sides, we have 2x dx dt equals 2z dz dt. And we can divide both sides by 2 right now. Get rid of those. Okay, we're going to put in negative 1 for dz dt, 14 for z. And again, we're going to have to figure out what x is. Okay, same thing again. So we go back to the fact that it's still a right triangle. When z is 14, we know that 3 squared plus x squared equals 14 squared. Okay. So then we can figure out what x is, because I need that to plug in. Did anyone figure out what that is? Yes. 13.67, I'll write 675 roughly, okay? And that's what we have to plug in there. And now it's just, where are we going to go? Okay, so we plug in for x 13.675. dx dt is what we're looking for. Z, we have 14, and dz dt is negative 1. Now we just divide each side by that 13 point. Okay? Anything else? Right triangles. Pythagorean theorem. SOHCAHTOA. Yes. What was number 6? What was the answer to it, or? Did you get that, or do you want me to go over that one? Sure. Okay, so two trucks start from the same point. One truck travels due east. So here's the point they're starting from. So one truck's going east at a rate of 50 miles per hour. The other truck travels north at the rate of 60 miles an hour. So the one that's going east at 50 miles per hour, that's dx dt. Do you see that? And it's positive. And the one that's going north, that's 60 miles per hour. So dy dt is 60 miles per hour, also positive. At what rate is the distance between the two vehicles increasing? So what is dz dt? This was probably the hard part for you, because it didn't say when x equals or when y equals. It said when t equals 1.5, right? So kind of the same start as all the other times. We start out with Pythagorean theorem. X squared plus y squared equals z squared. We differentiate both sides. But when it comes to plugging in numbers, to figure out what x is, to figure out what y is, you have to multiply rate times time to get distance. So if you're traveling so x is traveling 50 miles per hour for 1.5 hours, it's 75. And, oh, okay, how's it? You okay with the rest of it? Okay. All right, let's talk about similar triangles. Oops, not that one. Okay, so this is the famous shadow problem. So in this problem, a man 6 feet tall, I'll make him look more like a man, short legs there, walks at a rate of 5 feet per second toward a street light that is 16 feet above the ground. At what rate is the length of his shadow changing, and they labeled that S already, when he is 10 feet from the base of the light? Oh, good. Hi. Thank you. Do you have your homework, Joe? No? Okay, so they've labeled everything for us, which is nice here, right? So we know that this distance between the guy and the lamppost, that's changing, so we call that x. And we call the length of the guy's shadow s, right? His shadow, if the light's coming from over here, here's his shadow over here. That's okay, so let's figure out what derivative they gave us. A man 6 feet tall walks at the rate of 5 feet per second toward a street light. What length is changing at 5 feet per second? Yeah, x. So that's dx dt. Now, do you think we should make dx dt positive 5 or negative 5? Negative, because x is decreasing. Good. At what rate is the length of his shadow changing? So what are they asking us for? dx dt. When he is 10 feet from the base of the light. So when, what equals 10? Yes, x equals 10. Nice. So we got our setup. Now, some people are going to say, oh, this is a right triangle and has the sides. I'll use Pythagorean theorem, but you know nothing about the hypotenuse, so you can't. So you have to see, you see there are similar triangles here? So to write our equation, we're going to write a proportion here. So I just need one brave soul to give me a possible proportion here. Because remember, there are different ways you can do it. Awas? Mm-hmm. Very nice. We'll just step back and make sure we're okay with that. So he said S is to 6 in the little triangle, as the whole thing, x plus s, is to 16 in the big triangle. You see that? Now, once you set up your proportion, you're going to cross multiply and clean this equation up before we take the derivative and do the same old thing. So let's cross multiply. So we have 16s equals 6x plus 6s. And we don't need s's on both sides, right? Can we just subtract 6s? So we have, if we subtract 6s from both sides, we have 10s equals 6x. You want to divide each side by 2, clean it up a little more? Maybe make it as simple as possible. It's always good, before you start taking derivatives, if you simplify. So if we divide both sides by 2, we know that 5s equals 3x. Okay, that's a good equation. What do you think we're going to have to do now? Derivative with respect to t. So what do we get on the left side of the equation? 5 ds dt, good. And on the other side, 3 dx dt. Okay, let's fill in. We're looking for ds dt. And we know dx dt is negative 5. See, interesting, there's no place to put this 10. So in other words, x doesn't matter. It doesn't matter how far away he is. It doesn't affect the rate at which the shadow is changing length. Okay, so negative 5 for dx dt. So 5 ds dt equals 3 times negative 5. That's a bad 5. Okay, so ds dt equals negative 3. And what would the units be? Feet per second. So that means as he's getting closer and closer to the lamppost, his shadow length is getting shorter and shorter. Does that make sense? You ever notice that, right? Like it's more overhead? Yes. This is as he's walking, okay, his shadow is getting shorter and shorter at a rate of 3 feet per second. Got it? Anyone have questions on that part? No? All right, let's see what else they want to know here. At what rate is the tip of his shadow moving? Okay, so here's the we want to know how fast the tip of his shadow is moving, because a couple things are going on here. The tip of the shadow is moving, one, because it's connected to the guy, right? And the guy, he's walking at 5 feet per second. And also, it's moving because the shadow length itself is shrinking at 3 feet per second. Right? So we want to know at what rate the tip of his shadow is moving. So what we need to do here is we need to call this whole distance here some other letter. What letter would you like to use for that? You want to use A, don't you? You've been dying to use A. Should we let her use A for that? No. Oh, I'm sorry. Tom said no. All right, we'll let her use A. Okay. So if we want to know at what rate is the tip of his shadow moving, I need to have like a fixed other end here. So what are we looking for in this second part? At what rate is the tip of his shadow moving? So, well, yeah, that's what A equals. We're going to get to that in a minute. But if this whole distance here is A, the distance from the lamppost to the tip of his shadow, and we're looking to see at what rate is the tip of his shadow moving, what derivative are we looking for? dA dt. Okay, so at that moment. So now, yeah, I need an equation with an A in it, so when I take the derivative, I have a dA dt. So, like you said to me 1 second ago, what is A equal? X plus S, right? Time to differentiate, right? We already know dx dt. We just figured out ds dt. So when we differentiate, we got it. So dA dt, the rate at which the shadow tip is moving, equals dx dt plus ds dt. And remember, dx dt was negative 5. and the SDT was -3. So the tip of his shadow is moving pretty quickly, right? It's moving 5 feet per second because the guy's moving 5 feet per second, but also it's shrinking at 3 feet per second. So the tip of his shadow is moving at a rate of -8 feet per second. And think about that next time you're walking around outside. Look at your shadow. All right, so that's a classic. We're good on that one? The other one I have to talk to you about today is the cone problem. This also was from an AP exam. It was a free response question, and it was a no calculator question. So this is exactly what they gave us. They said a container has the shape of an open right circular cone. Now, all that means, open just means there's no top on it, right? So it's a container, so you can put water in it. And they call it a right circular cone. In other words, the cone, if you took slices, they would all be perpendicular to the vertical. In other words, it's not like a tilted over cone. So you can ignore that. The height of the actual container is 10 centimeters, and the diameter of its opening is also 10 centimeters. Now, water in the container is evaporating so that the depth H is changing at the constant rate of -3/10 centimeters per hour. So a couple things going on here. You have the radius of the water and the height of the water. They're changing, right, as the water is evaporating out. But what's not changing is the radius of the container and the height of the container. So actually, I know they put the 10 up there, but I always like to get back to the radius. So if the diameter is 10, what is the radius of the whole container? 5. So that's not changing. Now you might be wondering, what does this have to do with similar triangles? Well, if you could take a slice of this cone, right, and just look at half of it, what you would see, you actually do have similar triangles here. You have, with the big triangle, you have its radius is 5, and its height is 10. And with the triangle here created by the water, if you want to look at it like here, it has the water has a radius of R and a height of H. Can you see that or no? See those slices? You see those similar triangles now? Okay. All right, so the first part, just like yesterday's, we saw one where they just try to lead you into getting some numbers you're going to need. It says, find the volume of water in the container. Oh, wait, we didn't translate anything yet. Maybe we should do that first. Yeah, let's do that. Okay, they gave us a derivative. It says the water in the container is evaporating so that its depth H is changing at the constant rate of -3/10 centimeters per hour. So using the labeling we have, what is that? Actually, DHDT. So that's DHDT. So that's what they gave us, DHDT. Okay. I think everything else is fine. Okay, so now they say, find the volume of V of water in the container when H is 5. Now, one thing they don't have on here is the volume of a cone. Does anyone remember what the volume of a cone is? Remember the volume of a cylinder? Remember a cylinder? It was just area of a circle times height? No? Pi r squared h. That's no, that's you're thinking of the 4/3 is with the volume of a sphere. All right. Well, the volume of a cylinder is just pi r squared h, and the volume of a cone is 1/3 that. So the volume of a cone, got to have that down here, because the water is in the shape of a cone, is 1/3 pi r squared h. That's the volume of a cone. Now, they're not asking us in this first part to find any derivative. They're not saying how fast is something changing. All they're saying is find the volume of water in the container when H is 5. Indicate units of measure. They're trying to get you on the right path. Well, that's good. I know that I can put in 5 for h, but the problem is I don't know what r is at that moment. Yeah. How'd you get that? Very nice. She just did like similar triangles in her head there. She looked at the whole container, right? So if she's saying if the radius of the container is half its height, then the radius of the water is half its height. Right? Now, the way you could do it, if you didn't see that, you could set up a proportion. Yes, yes. So if you didn't see that, if you didn't look at this and say, oh, the radius is just half the height, so I'm going to put in right here, right now, I'm just going to put in 1/2 the height while we're thinking of it. Okay, but to get at that, you could set up a proportion. You could say 5 is to 10 in the big triangle as, what would it have to be in the little one? R is to h. And then once you cross multiply and solve for r, you have 10r equals 5h. So r equals 1/2 h. Okay, so now, oh, I put h here, but now it's when h is 5, so actually let me make that a 5. So since the radius is half, since we figured out that the radius is half the height in this, when the height is 5, the radius is 2.5. Anyone know what 25 squared is? 25 squared? 625. So what do you think 2.5 squared is going to be? 6.25. Okay, so let me just keep these all looking apart here. All right, that would be the volume of water in the cone when the height is 5. Now, on the AP exam, you would not have to multiply that out if this was a no calculator section. You could leave that like that. All right. Oh, indicate units of measure. What do you think the units of volume would be in this problem? Centimeters cubed. Very nice. Right? If you're measuring length in centimeters, then volume's going to be measured in cubic centimeters. Right, so that was just the idea. What they did that for was to make you think that, oh yeah, how do I get the radius in terms of the height using similar triangles? So now they're asking us, find the rate of change of the volume of the water in the container with respect to time when h is 5. Indicate units of measure. Okay, so what are we looking for here? Find the rate of change of the volume of water in the container. dV dt. So this water is evaporating, the volume's changing. We want to find how fast it's changing. Okay, when h equals 5. Okay, so we got to go back to our equation. Now, we said the equation for the volume of any cone was 1/3 pi r squared h. Okay. I take the derivative right now of both sides with respect to t. I'll get a dv dt. That's great because I want that. I'll get a dh dt, and that's also good because I already know what that is. But what else am I going to wind up with if I take the derivative now? dr dt. And I have to go through the product rule. Do we know anything about the rate at which the radius is changing? No. So we got to get rid of the r. So we can substitute in. So what are we going to put in the place of r? Since we don't have r, we don't want r. 1/2 h. Okay, so we need to square out the half h and multiply it all out. What is this? If we clean this all up, can anyone tell me what this equation looks like? First square that, the half h, then multiply it out. 1/12, that's good. Very nice. Now we're on easy street. Okay. Because remember, we have the HTT, we want dV dt. See that? All right, so let's go ahead and differentiate. So dV dt equals, if you multiply 3 by 1/12, what do you get? 1/4. So we have 1/4 pi h squared dHdt. Nice. Okay. Now it's just plug and chug. So we're looking for dV dt. H, they told us, is 5, I believe. And dHdt was like -3/10. Oh, I forgot the square. That would have been bad. So all the numerators, 5 squared times -3, that'd be -75 pi over 40. And again, if this was the AP exam, you would not have to simplify it. You could just leave it. We could, I will leave it. But let's put some units on it. What would the units be for this? Centimeters cubed. Good. It was hour the time? Okay, I forgot that. Good. Okay, the other one. We can do one. We can do one more of these. It's a little one. But yeah, when they say indicate units of measure like that on the problem, if you don't, you lose a point. And that's, oh, it's only worth 9 points, the whole problem, so it's big. Yeah. Wait, for the what we just did now? Oh, right, right. Oh, so if you left your answer with centimeters squared times centimeters, I do believe they would take that. I don't have firsthand knowledge, like I haven't been there, but to me that's reasonable. That's good. Okay, we'll try one more of these. So cones, you always want to remember similar triangles, you know, that this is what comes up. So the last one here, C. Water is withdrawn from a conical reservoir, 8 feet in diameter and 10 feet deep, vertex down. So you know, here we're saying, so this is like a container, it's a reservoir, it holds something. And inside of it, you've got water. Right? Now the actual reservoir has an 8-foot diameter. I'm not going to use the 8 feet. What am I going to use? The diameter is 8 feet. It's 4 feet for the radius, right? That doesn't change. The actual container dimensions don't change. And it's 10 feet deep. So that the height of this whole thing, I probably don't want to put this here. It's going to be in the way. I'll put it over here. The height of the whole container of the reservoir is 10 feet. Now, inside of it, water is being withdrawn. So the radius and the height of the water is changing. So what should we call the radius of the water? R, of course, right? We're not crazy. And the height of the water? H. All right, so we got everything labeled. Let's just see, what derivative did they give us? Water is withdrawn from a conical reservoir at the constant rate of 5 cubic feet per minute. That's somebody's derivative. All right. dHdt? Why'd you change? Because you're right now. It is dV dt. Yeah, once you see the units, cubic feet, you know that's dV dt. Okay, so dV dt equals positive or negative 5 cubic feet per minute. Is the volume increasing or decreasing if water is withdrawn? Decreasing, so it's negative. Now, how fast is the water level falling? So what is that now? What do we ask for? What is dH dt? When they say the water level, I mean the height of the water. What is dH dt when the depth of the water in the reservoir is 6 feet? So when something equals 6, H. Okay, we got it set up. We have dV dt, we want dH dt, right? Oh, I'm going to start.
Good morning, Newfield. Please excuse this interruption. Your morning announcements will begin in just a few moments.
If I take the derivative now, we got a problem. I need to get rid of the r again, because if right. So if you set up a proportion, maybe you just see that the radius is 4/10 of the height. Is that, can you see that? Or you want me to I'll set up a proportion. So 4 is to 10 as r is to h. So 10r equals 4h. R equals 4/10 h. Okay, sorry.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'm just finishing this up for people at home. So we would just put in the 2/5 h here. We square it.
Olivia Bond led the team with 14 points and 5 rebounds. Savannah Bond scored 10 points. Megan Spina added 9 points and 6 rebounds.
SAD Club will be having their next meeting January 8th in room 227 after school. All are welcome, and officers will be decided.
The Environmental Club will not be meeting this week. Our next meeting will be Thursday, January 10th. See you then.
Today is Thursday, January 3rd, a B-Day.
Sorry, guys.
Have a
H
great
is 6,
day,
and that's -5.
Newfield.
Then I would just put in -5 for dV dt. We're putting in 6 for the height. And we're going to solve for dH dt. So 36 times 4, that's 144. And so, actually, I should put this, I'll put the pi up here so you can, oh, I can't move the pi. Okay. If I multiply each side by 25, I have -125 equals 144 pi dH dt. And then I would just divide each side by 144 pi. So that would be the answer, but I would like to put some units on that. What do you think the units for dH dt would be in this problem? What was length measured in? Is that centimeters or feet? Okay, feet per minute. Yes. Yeah. Right? Okay, so 3 times 4 75ths. Okay, that would be 420, and then we go down by 1. You good? So you got a couple homework problems tonight on this. It's not much, it's 4 questions, but they take a little bit of time because, with the cones you have similar triangles. So you got a cone, you got a shadow problem. That's another cone, another cone. Oh, well. All right, now let's see if I can stop this. Bye, kids.